Good day, everyone. Welcome to our session entitled Project-Based Learning in Action. This is teaching and learning concepts on electromagnets. I'm your learning facilitator, Rosemary Jane D. Ranches, a science teacher from the Regional Science High School for Region 2. Before we start, let us take note of the following session objectives. The terminal objective for this session is to demonstrate teaching and learning concepts on electromagnets through project-based learning. At the end of the session, the participants will be able to enrich their instructional skills as they walk through a project-based learning lesson on electromagnets, reflect critically on specific strategies to nurture creativity among science teachers and pupils, design, build, and test projects using concepts on electromagnets, and understand the factors that affect the strength of electromagnets. The most essential learning competency to be discussed in this session is on the relationship of electricity and magnetism in Science Grade 5 for the third quarter, week 6 to 9. This is to design an experiment to determine the factors that affect the strength of electromagnets. The performance standard for this MELC is learners will be able to propose an unusual tool or device using electromagnet that is useful for home, school, or community. So I hope in this session, I will give you an overview on the use of PBL. Maybe in this time of pandemic, as a teacher, you ask yourself, how can we demonstrate project-based learning or PBL to our lessons, especially in the new normal? Ang layo-layo ng mga bata, di ba? So dahil hindi natin nakikita ang ating mga mag-aaral, PBL is a way of letting our children to explore more on their skills and creativity while they are learning from home. In this new normal, we can give our students authentic problems for PBL lessons so that they will be motivated to do projects. Also, solving problems through projects is another way of letting them realize that they can help address problems at home or in their community, even in their simple ways. So in this session, we're going to walk through a PBL activity for learners who are connected online, and at the latter part, I'll show you a learning activity for offline learners. So let's do this session in a PBL way, in hopes that somehow you will be able to empathize how it feels like to be in the cycle of PBL. Okay, are you ready? Let's start with this figure. Okay, can you identify the objects that uses electricity from this figure? And what are these objects? Okay, you can answer through our chat box. Bigyan daw natin ng reward yung mga sasagot. Okay, let's have this question. In this figure, can you identify the objects that uses electricity and what are these objects? Okay, yes. The refrigerator uses electricity. And your airplane and car. Also the electric robot. Okay, next question. From the same figure, where would you find a magnetic field? From the same figure, where would you find a magnetic field? Okay, so you can find magnetic field from the car, airplane, refrigerator, and the electric robot. This is because of the presence of iron metals and motors. Okay. So in this lesson, we will discuss on the relationship of electricity and magnetism. Okay, so through projects, we will understand the relationship of electricity and magnetism. Okay? Since you are doing projects, let's consider first your safety. So electromagnets are generally safe for their various uses, but you need to take precautions depending on the context in which you use these materials. So safety must not be compromised and some ground rules need to be followed first. So here are the basic guidelines while working with your projects. So on your screen, we have first, avoid water or any liquids at all times. Always work with your dry hands. Handle sharp materials with care. And use appropriate setup and materials for your electromagnets. Number 4, use insulation when working with uh, electromagnets like rubber gloves and plastic. So keep your electromagnets from overheating. And if you do not know what to do, ask an adult or your parents for assistance. Observe cleanliness and orderliness at all times. Okay, so those are the basic guidelines that we need to follow while doing your projects. Okay, so I know you are now ready to build your project. So I'll give you now the problem scenario. In your community or barangay, the garbage collection and segregation department is having a trouble with the materials recovery facility project. So they have collected different types of metals and they need to recover 100% of iron metals from it. The barangay captain needs your expertise and asks you to build a prototype for waste segregation. He emphasized that you need to focus on the iron metals for fast recovery and recycling. You accepted the project and promised to help the barangay in solving the issue. So your role here is an engineer. You design your iron metal lifter or a project that segregate iron metals from different metals. Okay? Make your device work. And again, while doing your project, please take the safety precautions. For the project specifications, the project must attract iron metals. And for the materials, I'll be requiring you to use a large nail, a copper wire, dry cell and staple wires for the metals, or paper clips, art materials and scissors for the design of your projects. Since you're doing projects, your performance will be evaluated using the following criteria. So we have working device here, 40%, science concepts, 40%, presentation, 20%. On your screen is the rubrics for grading per criteria. Okay, so for our participants, may I just remind you that in project-based learning, the concepts must be learned by the pupil themselves. Just give them guides to explore the concepts needed for the competency or design a PBL by making it sure that the concepts needed will be learned throughout the activity or throughout the process or through the learning activity sheet. So they need to learn their lesson. It's like an independent learning. For the explorations, after you build your project, please be guided with the following questions. So this will guide you to understand the factors that affect the strength of your device. So we have here, what are the needed materials to construct your device? How did your device work? Where did the strength of your device came from? And how did you increase the strength of your device? Okay, so it's up to you if you want to research. Since you are doing your lessons online, you can have a research from the books, from the online books that we have, and other reliable resources. Okay? So in project-based learning, we let our learners explore on how to deal with problems and come up with their own unique idea and solution. So let's give them time to explore with their projects. On the other side, we cannot deny that there are learners who are not into active learning, that they cannot do even initiate a task. They cannot do independent learning unless they are guided with instruction. So let's let's look on that side. So we can have supplements in our LAS on what to do. Okay, with that, let's have this short clip on how to build an electromagnet or you may provide a link for the students or pupils rather.
Hello boys and girls, and welcome to Hoopla Kids Lab, making science super fun and super easy. Today I'm going to show you how to make your own electromagnet. This is an awesome experiment and one of the first ones that I learned. You're going to need some copper wire, a magnet, some metal objects, an iron nail, and a size D battery. The first step is to take your copper wire and very carefully wrap it around the nail in a spiral pattern. You might need an adult to help you with this. It should end up looking a little bit like a screw. Make sure that it's tightly wound around the iron nail. This is a very important part of the process. And make sure that you leave 2 lengths of wire on either end. Then curl it around to make sure that you get a better contact with your battery. Then very carefully line up the 2 ends of the copper wire with the battery, one on the positive end and one on the negative end. The battery will get very warm during this experiment, so make sure that you have an adult present and maybe something like a tea towel to cover your hand. Turn the battery onto its side to hold the wire in place. Then hold the iron up against your metal objects. You'll see that all of a sudden the iron nail has become a magnet. Isn't that the coolest thing you've ever seen? This is because the electricity flowing through the copper wire has passed into the iron nail, making it magnetic. If we remove the copper wire from the battery, you'll see that the nail is still slightly magnetic, but nothing near as much as it was a moment ago. This is because the electricity is no longer flowing through the metal. Why don't you see if you can still pick up a few other objects? And there you go. That's how you can make your very own electromagnet at home.
So, from that video, you will make your own project to solve the problem in your barangay, such that you will design a prototype of a project or a device to segregate iron metals from the different metals in your MRF facility. So I will give you 2 days to build your project, and we will meet online to report the results of your learning. For the offline learners, they will be having a learning activity sheet. So a sample is on your screen. In this LAS, we have a brief introduction about electromagnetism and few reminders in doing projects related to the succeeding activities. So you just remind your pupils to follow the guides for their safety. Okay, the first activity for this LAS is a project-based learning also. We have a problem scenario here that can be done at home. So in this offline LAS, I did not yet introduce the big project. They will be constructing at the end of the lesson. So unlike for the online activity, we gave it as a driving question or scenario to solve. This is because for the online, they have their online ways to research for something to build. Nasa fingertips na nila. So, hindi na tayo nagpasikot-sikot, diniretso na natin sila. However, in this offline LAS, we started with building the electromagnet, the basic part of their big project. Baka kasi matakot yung bata since wala na nga siyang internet connection or gadget, baka umiyak na lang yung bata pag binigay na natin kaagad yung kanilang grand performance task. So, unti-unti lang tayo. So, on the first, on the building of their electromagnet, and on the second, we have the explorations hanggang sa mabuo nila yung project on the third or fourth activity. Okay, just in case the learners do not know what to do, there are figures in the LAS for the learners to follow or serve as a basis for them. So, kahit hindi siguro pa rin nila maintindihan, andyan naman siguro ang parents or adult family member na pwedeng mag-assist sa kanila. So, make sure that the figures are properly labeled for their consumption. So, this is a project-based approach. So, hindi tayo naglagay ng step-by-step procedure sa mga na mga pictures or even directions. So let them design on their own. Just give them the basic on how their electromagnets look like. Okay, in their LAS, we have this. So let's study this. Sabi niya doon. So the content they need to learn is on your screen. So we have here the main parts of an electromagnet and how the electromagnet works. In the activity 2, this has something to do with the strength of electromagnet. So this is a continuation of the first activity. If you did not construct your electromagnet in the previous activity, you cannot test the strength of your electromagnet. So dito po makikita natin na dapat may progress yung bata habang ginagawa niya po yung project niya. So, sa umpisa, gumawa lamang siya ng electromagnet. Sa pangalawa, mag-explore na kung ano nga ba ang pwedeng gawin doon sa electromagnet. Okay? In your LAS, there are tables there for your observation. So, just fill in so that you may observe how the factors affect the strength of your electromagnet. So we have here 3 tables. We have the number of coils, number of batteries by increasing the amount of current, and then changing the core component of the solenoid. So in the second activity, actually, it's not a project-based. This time, ang ginamit natin is a guided inquiry activity. Makikita nyo sa LAS, meron siyang mga directions and then few questions. So there are procedures given on how to explore their electromagnets. So unlike in the online learning, we did not provide a procedure, but we gave this as a guide question for their exploration so that they will not miss the most essential learning competency or most essential learning content. The learners who are learning offline will have the same problem scenario as well as the rubrics for the evaluation of their project. So, parehas lang po tayo ng problem scenario. For all the learners, both online and offline, we have a worksheet requirement for their project. So, parte siya ng kanilang paper or kanilang report. So, the worksheet will serve as their guide to understand the important concepts they need to learn during the process. So, we have here the project design. So, they need to measure the dimension of their project. Also, they will indicate the components of the project. So, dito sa online, bakit may mga component na nilagay dyan? So, mag-iisip yan. Magre-research sila. What are the best way to strengthen the device or the project they are making. And also, as an evidence, they need to attach a photo or drawing of their device with front and side views. So, kung gusto ninyong i-require na may mukha sila, better po. So, malalaman natin na talagang ginawa nila yung kanilang project. As part of their worksheet, they also need to report on the variables tested for their project. So, example here, we have the description of the variable as they use a nail core with 10 coils using a 1.5 volts AA battery. And the result for this variable tested is the project picked up 12 paper clips and some fell when raised. So, parang ganun po yung pwedeng maging sagot nila on their testing. So, actually, the worksheet will guide them to the most essential learning competency. So, you will also be submitting the output project and your report after this LAS. And I will give you 2 days for the offline learners to build the project. Okay, just like the online learners. Okay, for this time, I hope you are now done with your project. So, it's time for your presentation. So, let's just suppose that the time frame for the project making and learning has ended. So, you present your project using the following guides. First, how did you do your project? Second, how did you learn? And third, how did you come up with your working device or your project? Okay, so for the learners doing their tasks offline, you can record yourself or ask assistance from your parents or family member to record your presentation. If you have no gadgets, you may opt to have a written report or presentation or through phone call. From your presentation, it's time to elaborate your learning. And for the online learners, in-depth understanding of the concept was prepared and uploaded in the virtual classroom. For the learners doing their tasks offline, it is already in your learning activity sheet. So just read and learn. Well, at this point, since the learners already explored their projects designed to target the needed competencies, the learners already have their own learnings about electromagnets. So you only just need to correct the misunderstood concepts if there's any, introduce to the concepts they have not yet explored, and elaborate more on the concepts they have presented. On your screen is an introduction of electricity and magnetism. So let's just go over with these concepts. The connection of electricity and magnetism was first elucidated by Michael Faraday and James Maxwell because of their findings and inventions. So by inspiring the learners with the invention of these two scientists, may encourage the learners to do projects, more projects. Yes. So let's just discuss the concept of electromagnet. I just thought you might need this. So magnets produce a magnetic field. However, magnets are not the only thing that can produce magnetic fields. It can also be created by moving charged particles such as electrons. Arranging wire in a coil and running a current through produces a magnetic field. This is called electromagnet. And putting a real magnet inside can shove the magnet back and forth depending on the current direction. This is what we call solenoid. A moving electric charge in a wire creates a magnetic field. So the polarity of the solenoid depends on how the current moves. So in this case, as the positive end of the battery is directed on the left, the north polarity exits in that direction also. So electric current is the term to describe the electrons moving through a wire. If the current is turned off, there is no longer any moving charge and the magnetic field surrounding the wire also disappear. Unlike magnets, the magnetic field is permanent or semi-permanent. That is why electromagnets are also known as temporary magnets. They are magnets that can be switched off. Electromagnet is a type of magnet in which the magnetic field is produced by an electric current. So the current through the wire creates a magnetic field which is concentrated in the hole or center of the coil. So the three major components of electromagnets are iron core, solenoid, and the power source or the batteries. So the iron core or the iron nail used in your project as a magnet and can attract magnetic materials such as iron, nickel, and cobalt. So in your screen is the relationship of the strength of electromagnet and the number of coils of the solenoid, such that the strength of magnetic field increases as the number of turns on the coil increases. The strength of your project may also be because of the power source or the amount of current flowing through the wire. This is due to the increase of the current flow through the wire of solenoid. So the magnetic field around your device will also increase. So thereby, affecting the strength of your project. So with the use of iron core, just like the iron nail, the magnetic property of an electromagnet also increases. This is because iron is a ferromagnetic material, and it is one of the property of magnets. So other magnetic materials include nickel and cobalt. So to wrap up, the factors that affect the strength of electromagnets are number of coils, the amount of current flowing through the coil, and the use of iron core. The strength of magnetic field can be increased by adding more turns of wire to the solenoid by increasing the amount of current passing through the wire and by using an iron core of the solenoid. Electromagnets are useful, so it is one of the most electrical devices in use. They can be found in stereo, speakers, headphones, DVD players, video recorders, television radios, electric fans, wind turbines, laptops, cell phones, and anything with electric motor. Electromagnets is Electromagnets are a great example on how electricity and magnetism are related. So it is important on how these appliances and technologies work. In television, it generates electron beam and causes it to scan the picture area. So in electric fans, if current flows through the motor, the electromagnets rotate. So this causes the rotation of the blades of the electric fan. Also, in industries, they are using electromagnets to transfer metals from one place to another, including scrap metals, cars, and trucks, which are made of iron metals. Now you know why your device can solve the problem in your barangay. So maybe you can explore more on the uses of electromagnets. With your project at hand and the learnings you have taken, it's time to reflect on your outputs or projects. So let's talk about your experiences this time. You will write your reflection on your journal and do something about it. Also, if you want to improve your project, you can benchmark on the others' work and improve your project. Take note, dear teachers, in PBL, reflection or feedbacking is necessary in the cycle so the students will improve their skills and knowledge. So give your learners a second chance to improve. In this way, they will develop their skills and love for learning. So after all the project making, presentations, discussions, reflection, and feedbacking, we can now assess the learnings of our learners. So here is the link of your quiz. So that's the end of the simulation of PBL on electromagnet. What we did actually is the cycle of project-based learning. So we find the problem, we think of ideas to solve the problem by building projects. So in our case, we plan and then we build a prototype. And of course, we test the functionality of the prototype. It's not just a dummy. In doing PBL, we are actually practicing the scientific and engineering process of learning. So what are these processes and skills? It's actually asking questions and defining problems, developing and using models, planning and carrying out investigation, analyzing and interpreting data, using mathematics and computational thinking, constructing explanations for science and designing solutions for engineering, engaging in argument from evidences, and obtaining, evaluating, and communicating information. So in project-based learning, it is essential to give the learners a true scenario in the community so that they feel that they are the problem solvers for the community. And this will encourage them to learn more and build more projects. So we should enlist the learner's creative side. Di ba po ang mga bata, ang dami nilang naiisip na gawin. So let them build and develop their own projects. Give your pupils with guides and worksheets in analyzing and interpreting data to have an in-depth inquiry of their project. So as you develop your LAS later, please consider the scientific and engineering skills. So let's get ready for your PBL lesson. You will be preparing your LAS for this new normal. Please try to think on how to utilize PBL in your lesson. So here are the guide questions for you to start with your PBL lesson. So first, is there a pressing issue or problem in the community that you would like to solve? Make a PBL activity sheet and that you think your learners will be able to come up with a solution. And then align your PBL activity sheet to the most essential learning competency in science. Before I end this session, dear participants, let's reflect on this quote by Albert Einstein. It is the supreme art of the teacher to awaken joy in creative expression and knowledge. That's all. Thank you for being with me.